My name is Derek Sanders, and today I want to talk about local storage in cloud, why major cloud providers like AWS, Azure, and Alibaba Cloud are bringing NVMe SSDs directly onto compute nodes, and why the architecture behind it is harder than it sounds. Local storage addresses the concern of latency. Remote block storage like EBS adds network hops, typically tens to hundreds of microseconds. But applications like databases, in-memory caches, and ML checkpointing need near bare metal NVMe performance, single digit microsecond latency. Local SSDs eliminate that network penalty while also being cheaper per IOPS because you avoid the network fabric entirely. All major cloud providers now offer local disk instance types for exactly this reason. The problem addressed by the paper is what they call the impossible triangle. You want three things at once: high performance, meaning low latency and high throughput; low cost, meaning efficient use of hardware without loaded software stacks; high reliability, meaning data survives disk failures and host crashes. The problem is that traditional architectures can only optimize for two of these at a time. If you replicate data remotely for reliability, you pay latency costs. If you keep everything local for speed, you risk data loss. This trade off is a central design challenge. Alibaba Cloud went through three generations to attack this problem. The first generation, Espresso, moved the storage stack into user space with kernel bypass and polling based I/O. This cut latency significantly compared to kernel based drivers, but burned CPU cores on polling and still faced a reliability gap. The second generation, Doppio, offloaded I/O processing to hardware, specifically custom DPU and FPGA accelerators, freeing up host CPU and improving both throughput and efficiency, but it still treated local and remote storage as separate planes. That's where the third generation comes in. Latte is the breakthrough, a converged architecture that finally breaks the impossible triangle. The key idea is simple but powerful. Use local NVMe for the hot I/O path, reads and latency sensitive writes hit local disk first, and then replicate asynchronously to EBS for durability. A unified data plane merges local and remote storage under one abstraction, so the application doesn't need to know where data physically lives. Hardware offload handles the replication and consistency. The result? Local disk latency with cloud grade reliability at lower cost than pure remote storage. To wrap up, three takeaways. First, local storage exists in cloud because latency sensitive workloads simply cannot tolerate network attached storage. Second, the impossible triangle of performance, cost, and reliability is real and no single tier architecture solves it. Third, the solution is co design, tightly integrating software, hardware, both local and remote storage tiers into one converged system like Latte does. This is the direction cloud storage is heading, and it's a great example of how systems research drives real infrastructure at scale. Thank you.